All right, we're going to just start 2.2 today, and we're actually going to finish it next week. So if you don't get totally done with the practice part that I want you to do today, it's okay. It's not homework. You'll get it done Monday. But Friday, you will have a quiz over what we did on Monday and Tuesday, as well as what we're covering today. So try to be ready for that. You will get to reassess on those skills again next Friday as well. So, but still do your best. So we talked about axis of symmetry. It was that line that divides the parabola in half, right? Goes a vertical line, goes straight through the vertex. And we've been dealing with vertex form. This is how we graphed them in 2.1, where H and K are the vertex, okay? And A is got either the stretch or shrink, and if it's negative, that's a reflection. Standard form is new to us, and we're going to cover that today, okay? This one, just by looking at the equation, the only thing you can see is the y-intercept, and that is this, because the y-intercept is where x is 0, so these would all become 0, and you'd be left with y equals c. So that's the y-intercept, where vertex form, it gives you that vertex. So it's a little bit easier to graph, but we can still graph using standard form. So let's talk about some of the properties here. So here's I'm looking at the one over here first, okay? It has A being positive, so it's going to open upwards, okay? This is a positive number in front of x squared. Remember, we talked about what is x squared multiplied by, okay? Because I told you about those points to remember. It's whatever's in front, that's what it's doing to x squared, okay? Still works the same with standard form. The parabola opens up. In this one, it's opening down because if A is negative, okay? So this is telling us it's negative, okay? Oops. The graph is narrower when the absolute value, of A is greater than 1. So we just look at the number, we ignore the negative, remember? If that number is greater than 1, it's a stretch. If it's less than 1, it's a shrink, okay? So this says it gets narrower, but we like to think of it as it stretches up. Okay, it does get skinnier, but it's because you're stretching higher. The axis of symmetry, this is how we calculate it. This is the x value of our vertex. Okay, so this is in the form ax squared, so the number in front of x squared is a, plus bx, so the coefficient of x is our b, and c is the constant. And we use those to we use the a and the b to find our x. So this is something you need to remember. X equals negative b over 2a. So if I find our vertex, that's the x, and then you have comma, the y, which is you take the equation and you're plugging x in. And so we'll do some examples of that because that probably just went right over your head. The y-intercept is c, so it gives you that 0, c. Okay, we have max min values. We've talked about the vertex being the lowest or the highest point. So it's the lowest point if it's opened upwards, so it means A is positive. It's the highest point if A is negative because it's opened downwards. Okay, our domain is always all real numbers, which is negative infinity to infinity. And the range is whatever this y value is to infinity, and in this case it's negative infinity to whatever that y value is, okay? So the max value is just whatever this y value is when you're trying max or min or max, whichever. I'm mixing them up, okay? And we're not going to talk about intercept form today. We're saving that for Monday. So let's just get started because I just told you a lot of stuff. So, all right. So it wants us to graph the function, label the vertex, and the axis of symmetry. Then find the max or min. It doesn't have both. It has one or the other. Describe the domain and range, and where the function is increasing and decreasing. So let's just start by graphing it. This doesn't tell us to state our transformations like we did in 2.1, but we could still do it. We have a reflection, a stretch. That moves us right 1 and up 3. Okay, remember everything except for the x squared itself, but we don't need to do that for this part. But I can look at this. This tells me the x of my vertex. This tells me the y of my vertex. So my vertex is 1, 3. Remember, the x is always the opposite of whatever that tells you. So if that says -1 or -1, it is a positive 1. So that means we go right 1, up 3, and we put our vertex. So I make it kind of bigger so I know that's my vertex, my main starting point. Okay, let's go ahead and finish graphing this. So I have those points to memorize. Remember those? 0, 0, 1, 1, 2, 4, 3, 9. We put in values for x, and the y is x squared. So I take those values of x and I square them, because that's my parent function. All right, now I do have an a in this problem. A is -2. It is multiplying x squared. It's multiplying the parentheses that x is in, and that parentheses is squared. So it's multiplying x squared. So I need to multiply the y, because remember, y equals x squared. So I multiply the y values. Well, 0 times -2 is still 0. 1 times -2 is -2. 4 times -2 is -8. 9 times -2 is -18. Okay. Well, we need to plot those from the vertex. Remember, 0, 0 is not the origin. That's my vertex, that big dot I made. So I'm going to go right 1, down 2, and left 1, down 2. This next point tells me I go right 2, down 8, left 2, down 8. And then down 18 is not going to fit on my graph. So that's all I have. Oops, I missed my, I'm going to redo that. I almost missed my vertex there. Okay. So I have my graph. There it is. Then it wants us to label the vertex. Okay, so this is the vertex, and it is the point -1, or no, it's not. It's +1, 3. Then it says, and the axis of symmetry. So let's draw that axis of symmetry. It goes through that vertex. Oh, you can't see that yellow very well, probably. Let me change that to, decisions, colors. Okay, let me have it. Okay, there you go. Here's the axis of symmetry. It is that vertical line that goes through the vertex. So this is the line x equals, and the x value here is 1. Okay, so that's the axis of symmetry down here, x equals 1. Make sure you have that x equals. If you just put the number 1, you're not telling me anything but a number, okay? And it means nothing, so make sure to put that. All right, the min or max. So let's do, figure it out. I'm sorry, that's what I was trying to say. So if I look at this, I try to find the stopping point. I see that it has arrows going. So that means right here is the highest point. So to me, that's a max because that's as high as it goes. And it is just the y value. So it has a max of 3. Okay, we don't say min. It has a max. The domain, well, it's the same domain we've had for absolutely everything. It's going left forever and right forever. So -infinity to infinity. That's what those arrows on the end are doing. Range, how far down is it going to how far up is it going? Well, it goes down. Whoa, sorry, it erased. It's going down infinity because that's where the arrows are pointed. And then it goes up to that max number, which is 3. Now let's talk about increasing and decreasing. So when I drew this, my parabola, if I draw from left to right, that's how we read from left to right. I went up, hit the vertex, and I came down. So I was drawing and I went up, hit the vertex, come down. Okay? My intervals of increasing and decreasing are, where is that happening? Increasing is going up, so this would be increasing. Decreasing is where it goes down, so that is decreasing. All right, so I just take that domain, the x values, and that's how I write the increasing, decreasing. I'm just breaking the domain, okay? So use the x values. Might want to put yourself a little note, not the y values. So it is increasing from negative infinity until it gets to x being 1. Now, at 1, it is not increasing. So it's negative infinity to 1, parenthesis. It is not a bracket. At 1, it's actually a horizontal line, which isn't increasing or decreasing. So if you ever take calculus, you'll get to where you talk about that, but we're not that far yet. So just don't put a bracket, okay? Decreasing, on the right side, it's now falling. It's going down away from that vertex, okay? And so that started at 1 and went to positive infinity. So you see how I took that domain, the ends, and the x value of the vertex is just where it breaks. Okay? So that's all the parts. That was a lot. Okay? So I'm going to end this video to make sure everyone has time to catch up on their notes and then start video 2 to continue.